So, good afternoon, everyone. Uh, Today is the fourth live class on numerical methods for engineers, and we'll get started. So, to start with, we will go through a quick recap of what we have learned so far. And we have seen, so far, we have seen linear systems and numerical techniques to find solutions of these linear systems. So, the ones we have seen so far included a few iterative techniques in which we learned Jacobi iterations and Gauss-Seidel method. Okay, and among the direct techniques in the last class, we had seen Gauss elimination, and in Gauss elimination, we started with what is the idea of elimination, and then we moved ahead and saw the graphical interpretation of this, and then we also tried to draw a correlation between how do we actually solve these systems of linear equations and how we used to do this in school and how we do it in Gauss elimination method. Okay, so even for the same, we had gone through the algorithm and one example of Gauss elimination. Okay, and also I will be uploading a separate tutorial on LU decomposition and Gauss Jordan. So I will make a separate tutorial and upload it on the YouTube channel. Okay. So let's see what we are going to learn for today's class. For today, we will be going to learn a few non-linear equations, systems of non-linear equations, and see a few numerical techniques to solve them. Okay. So before we get started with nonlinear equations, we will go and revise our basics on what are variables, what are called expressions, what are functions, and what are the types of functions. And lastly, we'll come and see what are equations. Okay. So from there, from the basics, we will extend our understanding to how nonlinear equations come into the picture and what is actually meant by finding the roots of an equation. Okay, we'll not directly see how to find out and what is meant by roots of nonlinear equations, but we will take some time and understand what is meant by finding roots of an equation, and then we'll move ahead from there. So additionally, we will take a look at why are we interested in finding the roots? What is there about the roots and what is the concept of finding roots and why are we interested to find the roots? Okay. So then when we are motivated enough and we understand the meaning of finding roots, we will go ahead and study a few numerical techniques used to find out roots for nonlinear equations. And two of the techniques which are used to find out roots for nonlinear equations comprise of the bracketing method and the open methods. Okay. So in bracketing methods, there are two types, which one of them is bisection and one is regular falsy. And in open methods, there are three types, that is a fixed point iteration, Newton's method, and secant method. Okay. So in today's class, we'll be going through the algorithm and examples of bisection method and secant method. And the others will be taken up a few by the next TA session, which is from 4 to 5. And Newton's method I will be explaining in the next live class or next Saturday. Okay, so let's get started with the basics. So in order to revise the basics, the reference that I have given here is literally from class 7 to class 12 of NCERT textbook maths. And let's see what each of these terms actually mean. So if we go ahead and ask ourselves what is meant by variables. So variables is anything, any quantity which has the ability to vary. So in maths, they take up forms like x, y, z, a, b, c, and all of these. Okay. So when we include a few additions, subtractions, or multiplication, division, any kind of these operations on the variables, what we get is known as expressions. Okay. So examples of expressions are like 4x plus 7 or 4x plus 5y plus 11. Okay, these are all called expressions. Now, let's see how are equations evolving from expressions. So when we set a few conditions on, okay, when we set a few conditions on these variables and expressions, and we provide an equality sign, we get what is known as an equation. So when we just had 4x plus 7 or 4x plus 5y plus 11, they were in the form of expression. Now when we put an equality sign and write 4x plus 5 is equal to 65, this is called as an equation. Okay. So now you can appreciate the fact that when there is a unique value of x that satisfies the above equation, the above expression, that is called as an equation. Okay. So now, can you all stop or pause for a moment and think about what is a function then? If we have seen variables, we have seen expression, we have seen equation. So when does functions come into the picture? Okay. So to understand functions, again, let's go back to expression and try and understand that function is anything which depends on a particular variable. Okay. So like this particular expression can be written as a function of x, because the only variable term that is present in this expression is x. Okay. Similarly, um, hello. Hi Tejal, can you hear me?
Yes, ma'am.
Okay. So I just got started with the class, so you can follow from here on and ask me if you have any doubts. Okay.
Yes, ma'am.
Yeah. So, just an overview to let you help catch with what I taught so far. So, I was giving an overview of what we had learned in school from class 7 to class 12, and we had come across terms like variable, expression, equation, and function. Okay. So, I till now explained that variables are basically those notations like x, y, z, a, b, c, which are used in the mathematical equations or expressions. When we introduce any sort of operations like addition, subtraction, multiplication, and division, they go ahead, and then we can write these variables in terms of some expression. Okay. Next, when we set these expressions and assign them a particular fixed value and use an equality sign, we get equations. So the next question that I was asking, that is, do you know then what is the difference between an equation and a function? Tejal, would you like to give any idea?
Ma'am, we write functions in the form of f of x or f of x comma y.
Right, right. So basically, you're very correct, Tejal. So basically, the idea of a function is basically when it depends on a particular variable. Okay. So as I was writing here, this particular expression depends on x. Okay. So to generalize this particular expression, we can write it as a function of f of x. Okay. Similarly, just like you said, we can also write f of x comma y. When an expression depends on both x and y, we write that function as f of x comma y. Okay. So that is the main idea of function. So here I'll just write an example, 4x plus 5y plus 11. Okay. So till now, if we have understood the different terminologies like variable, expression, equation, and function, let's try and understand what are the types of functions. So this particular concept on the types of function is taken from the book Play with Graphs for JEE Mains and Advanced written by Amit M. Agarwal. Okay, so if you want to read up on this, you can go, take a look at this book. So here let's understand what are the types of functions, and from here we will extend the idea to when does nonlinear equations come into the picture. Okay. So functions are basically of two types. That is, one is algebraic functions and the other is non-algebraic functions. Okay. So algebraic functions are basically the kinds in which we write down polynomials. Okay. So we will go ahead and see what is the general expression of a polynomial. But before that, let's see what are the kinds of non-algebraic functions. So the term that is given for non-algebraic function is basically called as transcendental functions. Okay, and those include all your trigonometric functions, exponential, logarithmic, inverse, and all the geometric curves like circle, parabola, hyperbola, and so on. Okay. Now let's go ahead and see what is happening in a polynomial function. So let's write down the general expression of a polynomial function, which is f of x is equal to a naught plus a1 of x plus a2 of x square plus so on till an of x to the power n. Okay. So, now we see that f is basically a polynomial function and f of x is known as a polynomial in x. Okay. So here the a naught, a1 and so on till an are basically the coefficients of x naught, x to the power 1 and so on till x to the power n. Okay, where n is basically the degree of the polynomial. Okay, so now when n is equal to 1, f of x can be written as a naught plus a1 into x. Similarly, when n is equal to 2, can you tell me, Tejit, what will be f of x when n is equal to 2?
A naught plus a1x plus a2x square.
That's it. Very good. Plus a2x square. Okay. So from here, I will initiate the concept of nonlinear equations where only when the degree of the polynomial, this degree of the polynomial is n equal to 1, these are all the systems of linear functions or linear equations. Okay. As soon as the degree of these algebraic polynomial exceeds n is equal to 1 and takes up values from n is equal to 2 to so on, these are called as non-linear polynomials. Why? Because as soon as we have n is equal to 2, as we saw in this case, this is the form of a quadratic. This is the form of a quadratic polynomial. Okay. Similarly, as the power goes increase, as we keep on increasing the degree from n is equal to 1 to n is equal to 2, 3, 4, they no longer stay linear, they become non-linear. Okay. So this is not only the set of equations that fall under nonlinear equations, but all the non-algebraic functions, which are the transcendental functions, which include trigonometric, exponential, log, and all of these, all come under the set of nonlinear equations. Okay. So to summarize, we can write that all the equations which include functions of algebraic polynomials of degree greater than 1, of degree n greater than 1, plus all non-algebraic functions which include the transcendental functions make up the set of non-linear equations. Okay. So, did you understand so far, Tejal? Any doubts, any confusion anywhere?
Yes, ma'am, I understood.
Okay. So now let's go ahead and understand how do we differentiate between this the idea of function and equation and what we have to learn for today. So function is basically when we have a value of x, there may exist a value of f of x. Now, why am I saying there may exist? Because imagine if you have a function written in terms of f of x is equal to 1 by x. So now if your x takes up the value of 0, now 1 by 0 is basically infinity and you won't get a definite value of f of x. Okay. But in case of function, what happens is for any value of x, there may exist a value of f of x, and you can plot the graph. As your x moves on, your f of x will move on, and it will have some value. Okay. But for equation, what happens is when there is such a constant put on the function, that is f of x is equal to 0, or f of x plus y if it is in two variables x and y, that is equal to 0, or any other particular constant, they have to abide by those constants and they cannot have unlimited values. Okay. So let's see an example, that is if we take 4x plus 7y is equal to 18. This expression or this equation can be written as a general form, and we can write it as 4x plus 7y minus 18 is equal to 0. Okay. So that is why every time we are writing the general form of these equations as f of x comma y is equal to 0. Right. So now for this equation, if you see, uh, so for only a specific value of x and y, this equation will be satisfied. Okay. So keep this general idea of function and equation in your mind, and this will be used as we will move on to understand the concept of roots. Okay. So now this is just a recap of what is nonlinear equation. So nonlinear equation, all equations that we had learned so far in first 3 weeks, they were all of polynomials with degree 1. But now we are going to learn about all those algebraic polynomials of degree more than 1 and non-algebraic functions. They constitute the set of nonlinear equations. Okay. So let us go ahead and understand what is meant by the roots of the equation. So right now I am not focusing on roots of nonlinear equations only, but in general, what is the meaning of roots of equation? Okay. So let's take the linear system that we had learned in the last class. So any linear system which can be represented by this form a1x plus b1y plus c equal to 0. Let's generalize and write it as f of x comma y. And another equation of a line a2x plus b2y plus c2 equal to 0. And let's generalize that and write it as g of x comma y. Okay. If we plot these two lines and if they intersect at a particular point which we called as the solution, we can appreciate the fact that the system of these equations have one unique solution because we can see that they are intersecting at one single point. Okay. But what happens in case of nonlinear equations? In case of nonlinear equations, just imagine we again have the x-axis and the y-axis, and a particular function f of x has a particular expression and it depends on x. Okay. So as to make your, explain your generalized format, I'm not writing any specific, but just imagine a particular expression which depends on x. Okay. And what if we have a function f of x which varies as shown in this graph by the blue line? Okay. So can you identify here any two functions which you can see in the graph? As in this particular function that I've written here is f of x, and can you try to draw an idea with respect to this linear equation how there were two functions interacting here, two lines intersecting at a point, and we were able to find the solution, right? So in this case, can you try and identify any two functions which are intersecting with each other, and we will try and find out their solution. So any guesses, Tejal, on this?
Ma'am, the line y is equal to 0
Mhm.
and f of x are intersecting at many points.
Very good. So, very rightly, as Tejal said, the two functions which we can identify from this graph is one is the f of x function that we have drawn, the blue line, okay? And the second function is basically the line y is equal to 0, which is nothing but the x-axis, and which can also be written as a function in the form of g of x, okay, or any function of x. So basically this function can take up any values of x, but its y value is set at 0. Okay. So just like when we were solving linear systems, what we were doing is we were trying to see two lines. This was line number 1 and this was line number 2, which intersected at a point, and we were interested in finding out their point of intersection. Similarly, when we have nonlinear systems like this, we really have no idea how many unlimited solutions can exist, because it really depends on the nature of the curve. So the nature of the curve that you can see here is that it intersects the x-axis at multiple points. Hence, if we imagine it in the same way as the linear systems, like this is one function f of x and this is one function which is y is equal to 0 or the x-axis or g of x, they intersect each other at a lot of points, okay? So each of these points, so basically we introduce the idea here that is, in case of nonlinear equations, we do not know whether there is just one unique solution. There may be one unique solution. So if you just uh, take it in this format, if you have a curve and it goes, and this is the nature of the curve. So this is the only point when it is intersecting the x-axis, then it might have one unique solution. But we really do not know what is the nature of the curve. So in such cases, we don't have an idea whether it has only one unique solution. And also, these red points that are marked in this graph are basically the roots of the equation, which is fx equal to 0. Okay. And in other words, we can also write it as the points of intersection of f of x, the function we have drawn, and g of x. In this case, it is the line y is equal to 0, or it is the x-axis. Okay. So now if we have a general understanding of what is meant by the root of an equation, let's go ahead and understand why do we need to find the root of the equation. Okay. So this part that I'm going to explain now, I have taken it from the book Numerical Methods for Engineers by Stephen Chapra. So you can go back and just read it once if you want to, get a few more details of this particular concept. Okay. So let's see why do we need the roots of equations. Okay. So for that, let's take an equation which is given by V is equal to G into M divided by C into 1 minus e to the power minus C divided by M the whole times t. Okay. Here V is basically the velocity of a parachute which is thrown in the air, and G is basically the gravitational force. M is the mass of the parachute. C is basically the drag coefficient. Okay, and that's it. T is the time. Okay. So, if we are trying to study this particular system, let's call this a physical system. If we are trying to study this particular system, and if we are given the values for the parameters here are the mass of the parachute and the drag coefficient of the parachute. So these are known as the parameters. Okay. Time is our independent variable, and velocity is our dependent variable. Okay. Um, Now, and this is the gravitational force. Okay. So, what happens is generally, if the value of the parameters are available to us, we will be able to find out and predict what will be the velocity of the parachute with respect to the independent variable time. So, as time goes by, what is the velocity attained by the parachute? Okay. But in real life, what happens is we generally do not know we generally do not know the values of the parameters. Okay. So suppose when we are trying to study a system, the systems that we try to study, we label them as black boxes. Why? Because we do not know basically what is happening inside the system. So in those cases, we have to find out the parameters. And how do we find out the parameters? That is, we will be given the time for which the study is being conducted and the velocity it has attained in so much amount of time, and the gravitational force g equal to 9.8 meter per second square will always be given. So with the help of that, we have to compute the value of the parameters. Okay. So in that case, what can we do? Tejal, any idea? I mean, have you come across any situation like this, or any idea what can be done in these cases?
Ma'am, first we'll have to calculate the values of the parameters.
Mm-hmm. Yeah, go ahead.
Then maybe we can find out the velocity.
Right. So see, what is happening here, no? The velocity and the time is sort of given to us. So I'll give you an example of the kind of experiments that I'm doing. So I basically grow these cancer cells in different medium and try to understand the growth of cells. So how much in number they are increasing, or how much in the area occupied is increasing with respect to time. Okay. So in that case, I can give you a draw correlation with respect to velocity and time. Is that my experimental results basically give me the value of time and velocity. Okay, but I do not know from the direct values of time and velocity. I do not know at what rate the velocity is increasing with respect to time. So I do not know the parameters. Okay, so basically I need to calculate the parameters. So any idea or any guesses how these parameters can be calculated? Like any intuitive idea or any understanding that you want to share?
Ma'am, maybe we will calculate many values of velocity and time.
Mm-hmm. From there,
Then
any. Mm-hmm.
we'll be able to generate many equations, and we have two unknowns. So we
Right,
can solve those two equations
right.
with the two unknowns.
Right, right. Your understanding is right. So I'll channelize you to like how we actually do it. Okay. So see, what happens is this particular equation that we had, right? We will try and rewrite this particular equation. How? That is, first what we will do is, I'll try to keep this in the picture. I'll just, okay. So see, this particular equation that we have, no, we will try and rewrite this. Okay, we will try and rewrite it and equate any of the sides, LHS or the RHS, to 0. So how can we do that? We can try and rewrite it this way. That is G by M by Gm by C into 1 minus e to the power minus C by M the whole times T minus V is equal to 0. You understood, Tejal, why we did this? Any confusion in this step?
Yes, ma'am, we
Okay,
are trying to find out the parameters, right?
yes, we are trying to find out the parameters, and in this case what we have done is, this was our physical system, right? This was the system that we were trying to study, and that system, what we did is, we basically, we have an equal to sign here, right? So we take this value, this velocity, to our RHS, and then we just equate it to 0. Okay.
Yes, ma'am.
So next
Yes.
step, what we do is, I just now told you that we have the values of velocity and time with us. Okay. So so let's set a condition now that we are only trying to find out the value of C. The value of C, we are trying to find out this parameter, which is C, which is the drag coefficient. Okay. So what we will do is, we know all other values. So we will rewrite this expression that we wrote here, expression number 2, I'll write it. So expression number 2 can be rewritten as a function of C, which we are trying to find out. And function of C is basically Gm by C times 1 minus e to the power minus C by M the whole into T and bracket close. Okay. So can you tell me what would this be equal to? Have you understood this part? Like if we write this particular expression as function of c, because c is the only variable that we are trying to find out, so what will this be? Any idea? Equal to?
0.
Excellent, excellent, very good. So this is the fundamental thing that we are trying to understand here. That is, we now know we are trying to find out the value of c, v and t given to us. Okay. So what we do is we rewrite our expression in such a way. So this will have, sorry, there is a small mistake here. So this will have this minus v is equal to 0. Okay. And since we are trying to find out c, which is the only variable here, we can generalize this entire expression and write it as f of c, which is now equal to 0, which we had already written. Okay. Hence, our entire complicated problem is now streamlined down to finding what is f of c, what is the value of c at which f of c becomes equal to 0. Have you understood this much, Tejal?
Yes, ma'am.
Okay, so if you have understood this much, this was the entire point of explaining why we are trying to find out the roots of the expression of the function. Okay, so in the graph what we saw is we were trying to find out the points at which this particular graph intersected the x-axis, right? So whenever it intersects the x-axis, those were the points when the function f of c, which is in the y-axis, those were the points when f of c is equal to 0, because that is the point when they intersect the x-axis. So we were trying to find out those values of c at which this f of c was equal to 0. Okay. So this is the entire meaning and why are we trying to find out the root of a function equated to 0. Okay. So have you understood this, Tejal? Any doubts so far? Any confusion?
No, ma'am, no doubt.
Okay. So now that we have understood this, let's go and see two different techniques by which we find out the solution of nonlinear equations. Okay. So let's once have a recap of what is meant by the root that we learned just now. That is, graphically, a solution or a root of f of x is equal to 0 refers to a point of intersection of that graph f of x and the x-axis. Okay. So if we take another example and we write f of x is equal to 2x plus 7, and we have to find out the values of x at which f of x is equal to 0, we will get just one value here, that is minus 7 by 2. Okay. Now, depending on the nature of the graph of f of x, this was just a linear system in one variable, it had just x. And if we would have also taken a linear system in two variables, imagine f of x comma y as 2x plus 5y plus 7. Okay, this is again a linear system because the degree of the variables are all 1. Okay, because the degree of all these variables are 1. Now, we do not know whether the kinds of physical systems we are going to study, whether they all follow these linear systems. So we are going ahead and introducing those systems which might not behave in a linear way and might be nonlinear systems. And in those cases, we do not know what will be the solution of those functions. Okay. So they may either have unique solution or they may have multiple solution, as we saw in the graph that the curve may cut the x-axis at multiple points, or it may have no solution. It may not cut the x-axis at all. Okay. So in those instances, so this is what we will go ahead and learn today. Okay. So let's now see why are we going to learn numerical techniques. What is wrong with analytical techniques? So in some cases, suppose let us take an example of e to the power 2x minus 2. So if we have to find out f of x is equal to 0, we can go ahead and solve this as e to the power 3x minus 2 equal to 0, where e to the power 3x is equal to 2. And if we take ln on both sides, this is going to become ln 3x is equal to ln 2. In the next step, this is going to become 3x of ln e is equal to ln 2. So x is going to become ln 2 divided by 3. Okay, because ln e base e is 1. Okay, so in this case, we were able to find out the root analytically. But always what happens is, in most of the physical systems that we will be studying, we cannot find out analytical solutions, and it is not actually easy to find out, or sometimes not even possible to find out these analytical solutions. Okay, those cases we need to learn numerical techniques. So, what are the kinds of numerical techniques that we are going to see for nonlinear sets of equations? That is, one is called as the bracketing method, and one is called as the open methods. Okay. So, in bracketing methods, the basic idea is that we have initial guesses of the roots in terms of a bracket. That is, whatever initial guess we have, that is around the root. One side, that is either on the left side, and that is on the left side and on the right side of the root. Okay. So basically, it is in the form of a bracket, and our intention is to shrink this bracket and merge to the root. Okay, that is what happens in bracketing techniques. What happens in open methods is that we just have one initial guess of the root, and we go on iterating it. We will see an example at the end of today's class, and we go on iterating it, and it merges to the root. Okay. So, for the bracketing techniques, the first bracketing technique that we will be learning today is called the bisection method. So, for the bisection method, let us go ahead and see an example and the graphical meaning and the algorithm side by side. Okay. So, if we take this example, f of x is equal to x cos x plus 1, what we basically do in the bisection method is that the function is given to us, and we need to find out the value of x at which f of x is 0. Okay. So we go ahead and set this expression as x cos x plus 1 is equal to 0. So our step 1 is basically to understand that what is our aim. Our aim is to find out that value of x at which f of x is 0. And let us have an overview of how does it look on the graph. So this is not the actual curve of how x cos x plus 1 looks, but I have kept it simple to give you the idea what is meant by the bisection method in terms of the graph. Okay. So if we have a function which looks like this that I have drawn, and we have the x-axis and the y-axis, what we are basically trying to do is we are trying to find out this point at which this curve intersects the x-axis, or the point at which what is the value of x at which f of x is equal to 0. Okay. So our step 2 is now to go ahead and identify the bracketed initial guess given to us. That is, for this question, it is given to us that the root lies between -2 and 4. Okay. Similarly, in general terms, it will be given to us that the root lies between a and b. So what we basically do is go ahead and imagine it in the graph that if the root lies at this point, A and B lies on either sides of the root, and we try and draw it in this way, which I've drawn with green highlight and orange highlight. Okay. Our second step is to basically compute the value of f of A and f of B. So we go ahead and compute the value of f of -2 and f of 4. Okay. So our f of x was x cos x plus 1. So for time's sake, I have done the calculation and kept it here so that I can explain you all more than writing. So f of -2, if you compute, you will find it as 1.83. And f of 4, if you compute, you'll get it as -1.61. The idea of what we are getting here by solving these, by computing f of A and f of B, basically in graph, if you want to imagine it, you will be able to get it this way, that f of A will lie above the x-axis, that is, it will be positive, and f of B will lie below the x-axis, that is, it will be negative. Okay. So when you compute f of A and f of B, your next step is basically to multiply f of A and f of B and get the condition lesser than 0. Why lesser than 0? That is, only if you compute f of A and f of B and you get a negative value, only then it means that you lie on either side of the root. A and B lies on either side of the root. Okay. So if A and B lies on, imagine A and B lies on both same sides of the root, then when you compute f of A and f of B, both are going to be positive. So that gives you an indication that the root does not lie in between a and b. But now, since let us take this example, that is, we have computed f of a, that is minus 2, and f of b as f of 4, and we found that the answer comes negative. Only because the answer comes negative, we know that the root lies between a and b. Now, our next step is to compute the midpoint. So we take these values a and b and we compute the midpoint. So basically, we calculate c with the help of a and b. So here in the example, we calculate c as equal to 1. Okay. Now, in the next step, what we do is we compute the value of f of c. So here we compute the value of f of 1 and we get it as 1.99, which is a positive value. Now that we have got a positive value, we go and identify the previous value of the function which had an opposite sign. So if we take, if we recall those values f of 2 and f of minus 2 and f of 4, f of 4 was giving us a negative value, right? So uh, it means that a, which was basically minus 2, can now be updated to a value of c is equal to 1, right? Because if you now compute f of a and f of b again with the help of f of 1 and f of 4, you will be getting a negative value. So that again means that the root now has shrunk between uh, minus 2 and 4 to 1 and 4. Okay. So again, the root lies between these 2 points. So we repeat this process. We again compute the midpoint of 1 and 4 and we get minus 2. And finally, we come to a junction at which the values of a and b has almost shrunk to the root and we arrive at the root. Okay. So this was the basic idea of bisection method. So did you understand, Tejal? Any doubts, any confusion?
Yes, ma'am. Ma'am, if value of f of 1 is negative, then what will happen?
So the value of f of 1 is negative. It means that it lies below the graph, right? It lies below the x-axis.
Yes, ma'am.
So what you're supposed to understand by that is you go ahead and, okay, I'll tell you once again. See, you're at this step, right? You have found out the value of f of 1 and it has come out to be positive, right? So you are saying, what if it was negative? Okay, let it be negative. Now what you will do is you will go ahead and identify the previous value, whatever it was. So just write it down again. You get it as 1 as positive and 1 as negative, right? So now you multiply the two. So you multiply this f of 1 with f of minus 2. So this is the negative value and this is the positive value. If you multiply, you will be getting, I'll write it here for you, f of 1 times f of minus 2. And you are asking what happened if this was negative. So if this is negative and f of minus 2 is positive, then this is going to be a value less than 0.
Yes, ma'am.
Right? So it means that the root lies between 1 and minus 2, or the other way around. It lies between minus 2 and 1. So the interval would have shrunk to this minus 2 and 1, which will not happen because the curve is set in such a way that the values of a and b were in this particular interval, right?
Yes,
So
ma'am.
that will not happen, that this will be a negative. But in case it was negative, you were asking. So in case it was negative, what would be the meaning is that the root would lie between those two intervals. Okay.
Yes, ma'am. The interval would be different.
Yeah, exactly. The interval in the beginning only it would be different. Like it would not be minus 2 and 4. It would have been something like minus 2 and 2. Like it would be in this range basically. It would have been in this range. Okay, and the curve would have intersected the x-axis in this particular range then. Okay.
Yes, ma'am.
So
Understood.
only because the value is positive, what we do is we compute, we again multiply, identify f of 2 and f of minus 2 and f of 4, and we identify in which interval it is coming negative. So in the interval it is coming negative, the value of either a or b is updated as c. And what if we keep on repeating this process, what happens is we come and shrink to the root, as we saw in this diagram. Okay.
Yes, ma'am.
Okay. So now we will see the last method, which is the secant method. How much time do we have? Okay, we have 10 more minutes. Good enough time. Okay. So now let us go ahead and see the secant method. So unlike the bracketing method that we learned, which is one of the bracketing methods is bisection, and regular falsi, which is another bracketing method, it will be taught by Rohit in the next class. Okay. So unlike the bracketing method, secant method is a numerical technique to find out solutions in which we do not necessarily bracket the root, but we take any random initial guesses, and two initial guesses we require for this secant method. Okay. So to start with, what we will see is that we start we start with two initial guesses, like in the graph. We can see x1 and x2. Okay, so our first step, as I've labeled A, is to identify these two initial guesses, and mostly this will be given to you in a question. Okay, the two initial guesses. The second step is to locate the points x1 f of x1 and x2 and f of x2. That is basically these 2 points. You have to locate the value of f of x, where it basically goes and intersects the x1 point on the graph, and you have to locate the value f of x2, which goes and intersects the point for the x value x2. Okay, so you locate these 2 points. This is your second step. The third step is to draw a secant that connects the two. So here comes the difference between a tangent and a secant. That is, if you have a curve, tangent only touches the curve at one single point, and secant crosses the curve at 2 points. Okay, so this is the secant that I have drawn. Let me highlight it for you. This blue line is the secant. Okay, so you draw the secant which connects these 2 points that I have highlighted here in red. Okay, now your third step is to extend the secant and find out the x-intercept on the x-axis. Okay, so this is your updated value and will be labeled as x3. Now what you do is, now you locate these points. Now you locate these points x2 f of x, so that is this point, and you locate this another point which is f of x3 and x3. Okay, then again what you do is you draw a secant. Okay, just by this process we go on repeating this process unless and until. So see if, okay, so now let's see, if we extend this secant we will come to a point x4. Now if we take x4 back, I will zoom in, I hope you can see it better now. Okay, so if I extend again x4 and find out f of x4, okay, we will see that we have almost, so from this point to this point, if we draw the secant, it will actually be the curve itself. Now if we extend to the x-axis, we will cut through the root. Okay, so this is the graphical idea of the secant method. So did you understand it, Tejal? Any confusion? So we'll clarify that first and then move ahead to the formula.
Yes, ma'am, I understood.
You understood? Oh, very good. So for the benefit of deriving the formula, let's assume that x3 is itself the root. Okay, x3 is the point where the curve cuts the x-axis. Let's assume that for now. So if that was the case, I will erase the x4 part. Okay, if that was the case, can you think and tell me what would be the expression of the slope of this secant? Can you tell me the slope of the secant, Sejal?
Yes, ma'am.
Yes.
F of x3 minus f of x2 divided by x3 minus x2.
Right, it would be x3. It would have been x3 if we were talking about this slope. Okay, so right now I'm asking you for this particular the slope of this secant, this line.
Yes,
Okay.
ma'am. Then it would be f of x2 minus f of
Yes.
x1 divided by x2 minus x1.
Divided by x2 minus x1. Very good. Okay. Now let's imagine we are trying to write the general equation of this secant, this particular secant, this blue line that I had drawn here. No, I'll erase these three. Uh, okay, this particular blue line that we had drawn, let us write the equation of this line. What happens when we extend it to the x-axis? Okay, and because we are assuming that x3 is the root of the equation, so let us find the equation of this line from here till here. Okay, so in that case, what would be the general equation of this line? Like the general equation, I have given you a hint here. If the equation of a straight line is y is equal to mx, and if you have 2 points, this would be the general equation. Could you tell me the expression?
Yes, ma'am. Uh, y minus f of x1
One.
divided by x
Um,
minus x1
mhm.
is equal to uh,
So, you know what we can do in this case is that we are trying to find out this particular line, right? So, let us try and concentrate on the second part of this line. Okay, second part of this line, and for the slope, we are taking the expression that we wrote down with the help of the slope of the secant. Okay, so the 2 points that you can focus on would be y value, which is basically y is equal to 0. So let this be one point and let x of 2 be f of x2 be another point. Okay. So what would be your expression? Y minus f of x2 equal to, yeah,
is equal to the slope that we have
slope.
calculated
Exactly.
f
Very
of x2 minus f of x1 divided by x2 minus x1
right.
into uh,
Into the two values of x's are, this is one value that we are trying to compute, and the previous value was x2.
yes, ma'am.
Right? So we can write that expression as y minus f of x2. So I'm just trying to focus on this second half, okay, this second half of the line that I have drawn here, because only when I extended this line to the x-axis I got the root, right, assuming that x3 is the root. Okay, so the line, the equation of the line can be written as y minus f of x2 is equal to the slope that we had written times the x values were x3 and x2. Okay, did you understand till here?
Yes,
Okay,
ma'am.
so now let's go ahead and solve this and see what is the expression for secant. What is the numerical formula that we will be using for the secant method? Okay, so what we are basically trying to do here is find out the value of x3, right? It is the next guess for the root. Okay, and when are we getting x3? That is when we are assuming that x3 is the root. The value of y is reducing to what? Any idea?
0.
Excellent. The value of y is reducing to 0. Okay. So now you can rearrange and write this as x3 minus x2 will basically be minus of f of x2, x3 minus x2. No, let me write it the other way around. Let me write it as so. Okay, let me write the slope on the top itself. So this is going to be minus of, so if that is set to 0, minus of x2 is equal to slope. Let us break down and write what is the slope. The slope is f of x2 minus f of x1 divided by x2 minus x1, right? And this value is x3 minus x2. Okay, so now what we will do is we will go ahead and rearrange the above equation and find out the value of x3, which is going to be, just bring this minus x2 to the other side of the equation. It is going to be x2 minus, what is it going to be, x2 minus f of x2 times x2 minus x1, if you bring this on the top, divided by f of x2 minus f of x1. So is this expression correct? Just check it out yourself once. x2 minus f of x2, x2 minus x1 divided by f of x2 minus f of x1. Is it correct?
Yes, ma'am. Yes, ma'am. I got the same thing.
Exactly. Okay. So now let us write a general form of this expression. That is, what if we are trying to find out fk plus 2? Why am I taking fk plus 2? Because if this is going to be written as x of k plus 1 and x1 is going to be written as xk. Okay. So what we are basically trying to find out is x of k plus 2, because you realize this, right? In secant method we are taking two initial guesses. So the first initial guess is the first initial guess is xk, the second initial guess is xk plus 1, and the third guess that we are trying to find out is xk plus 2. Okay, so what would be the general form? Xk plus 2 is equal to xk plus 1 minus of f of xk plus 1 times xk plus 1 minus of xk divided by f of xk plus 1 minus of f of xk. Okay. So, however complicated this may seem, but you understood from the geometry, from the graphical representation, why we are arriving at this expression, right?
Yes, ma'am.
Okay, very good. So, utilizing this particular formula, we will just solve one question. How much time do we have? We will just take 2 more minutes to just solve this one question. Okay. So, the same question that we had solved in bisection method, that is x cos x plus 1 is equal to 0. So, these are the two initial guesses given to you. Okay. So, now how to find out x3 is, can you try and solve this, the value for x3? So the value for x3, I'll also solve it with you. So the value of x3 is going to be x2 minus f of x2 times x2 minus x1 divided by f of x2 minus f of x1. This much is clear?
Yes, ma'am.
Okay. So now the value of x2 that is given to you is 1.5 minus the value of f of x2. If you compute it, it is going to be 1.5 cos of 1.5. Just remember that this the one that you'll be computing in calculator, set it as radian. Okay, because all these values are in radian. Plus 1 is basically your f of x2 times you will be doing x2 minus x1, which is 1.5 minus 1 divided by f of x2 is again 1.5 cos of 1.5 plus 1 minus of cos 1 plus 1, right? So 1 cos 1 plus 1. Okay, so when you compute this, were you able to find out the value? It's basically calculation, so no issues, you can do it at your ease. So the value that basically comes for this is 2.774. Okay.
Yes, ma'am.
Okay, similarly if you go ahead and compute the same for x4, the next value, the value for x4 is going to come up to 2.0229. Okay, so this is how you were the two questions that were given in the assignment regarding the secant method and the bisection method, you'll have to solve in this way. Okay, so were you able to understand, Tejal, all that we
Yes.
learned in today's class? Any doubt, any confusion, any comments?
No, ma'am. I understood everything.
Understood, very good. So now I will end the recording. Thank you for listening, and